Once you start to look, you'll find mechanical counters everywhere. From odometers to odometers, micrometers, and even odometers. But to understand the clever design that makes them tick, why this one is just a little bit different, and how that involves basically all your favourite pretengineers on YouTube,
what? That is ridiculous.
we're going to have to start at the beginning. A few months ago, I got a message from none other than Mr. Inheritance Machining, asking if I'd like to get involved in a little something his friend Eric from the UK was cooking up.
What the f*** are you doing in my kitchen?
This little something would later come to be known as Toolroom Takeover 2025, a major collaborative event that's probably best described as a machinist's secret Santa for Christmas in July, in August. The intro likely made it pretty obvious whose name I ultimately drew from the hat,
Alex.
and so you're probably wondering how I reached the conclusion that the best possible workshop-related gift for the biggest blacksmith on YouTube was a model mechanical counter. The man still has 10 fingers after all, let alone one so gratuitously designed. The thing you've got to remember is that, at least in the toolroom department, Alex pretty much got it made. I trawled hours of content, looking for a gap in his capabilities, and I just couldn't find one. Hey, just doing some research.
How many videos does this guy have?
The idea struck me like a hammer.
That's it.
A video title generator. With over 3,000 videos, there was no doubt in my mind that his ideas must be running dry by now. I mean, this is only my 14th, as long as we count the 10-minute monologue on drawers, which I think we should because it illustrates my point perfectly. But aside from being a blacksmith, Alex also an artisan blacksmith. So whatever form this video title generator was going to take, it had to be artisanal, which ruled out most of my usual tricks. And so I began on my journey to find a purely mechanical mechanism capable of spitting out a random, or at least pseudo-random, combination of viral video title elements. Now, I know what you're thinking, and it was my first thought as well. Why not just use a monkey at a typewriter? But even once you've found somewhere that can supply one, you can't ignore the difficulty and expense involved in acquiring a typewriter.
It's the best I could do.
So I continued my search, exploring all sorts of solutions. From gyroscopes to Geneva mechanisms. In the end, no assembly seemed better suited to spitting out indexed physical positions than the humble mechanical counter. At least when you consider I'd have to design, manufacture, and ship it to the UK, then write, shoot, and edit a video about it by the 15th of August.
Oh my goodness, it's already happening, Jamie. This is so exciting.
Because more important than the idea of a machine is careful consideration of the manufacturing and assembly process. The technical term for this is DFM, which stands for Don't Fucking Make It Impossible. And it's kind of a big deal, especially when you're the guy who has to make it all happen. So let's quickly take a look at how they work. If we strip everything back to its core, we end up with 3 fairly distinct gears. Firstly, the input gear is slightly abridged, so that for every full rotation, the second and central carry gear is only advanced by 2 of its 8 teeth. And with the help of a lack of half of its teeth, spends the rest of the revolution locked in place by this lip. A plain old 20-tooth spur gear, in constant mesh, matches the 2-toothed steps of the carry gear, giving us a predictably intermittent 1/10 of a rotation out per full one in. But while I'm sure there's a use for this 2-dimensional arrangement, it's not quite right for the odometer of awkward suggestions we're shooting for. We can get a little closer by slightly stretching the carry gear, which allows us to mount the input gear concentric to the output. And now that our input and output are axially aligned, it's possible to stack any number of identical stages right on top, depending on how many digits you're trying to keep track of. But counting to 10,000 isn't exactly nail-biting stuff. So when designing Alex's video title generator, I knew I'd need to make some changes. The first of which wouldn't have been possible without the support of Onshape. Unlike other CAD solutions that keep me tethered to my workstation, Onshape is entirely cloud-based and runs in a web browser, which means I can pretend I'm making progress on my projects from basically anywhere, on basically any device. Here's the thing. It's the 8th of July, so
I better get started.
And what better part to start with than the biggest and most complicated, which I'll be extracting from a convenient stack of pre-cut aluminium flat bar. At 160 millimeters abreast, and with about 99% too little stock removed, these stocky bits of stock fell smartly outside the capacity of my usual work holding strategies. Thankfully, unusual for me is pretty normal everywhere else, so drawing inspiration from some commercially available modular vice systems, I knocked up a bitey miter to pair with this urgently machined interim fixture plate, which by the end of this project had proved it could punch well above its weight. Op 1 for these tidal generating drums was designed to remove as much material as possible, as quickly as possible. So without so much as a spot, I sent a 13mm drill through the gaps in their soon-to-be spokes. Before switching to an incredibly shiny 12mm 3-flute. The impending adaptive clearing toolpath was right at the edge of my pucker tolerance, but a quick contour of the left and right edges and a gentle tickle on the top face in the form of a spiral toolpath helped to soothe my nerves. Even still, when it came time to start adaptive clearing, I made liberal use of the big blue feed hold button all the way to my Z- position and beyond. But while the initial results looked promising, there was no doubt the chip clearing situation fell entirely short of ideal, forcing me to babysit the roughing stage with a blowgun and an unfortunately unpictured furrowed brow. But aside from this ill-advised manus in machina moment, and despite the machine's measly 3000 RPM maximum spindle speed, the bulk of the waste was easily removed, and I could get back to the finer things. A 6mm end mill added 4 locating holes that would prove invaluable for Op 2, before cleaning up the crannies that would house bearing and shaft, and addressing the nooks between each spoke. These windows will provide a perfect view of the inner workings of the device, and reducing the weight as much as possible should help prevent bankruptcy due to the cost of shipping it internationally. The addition of some undeniably tasteful chamfers meant drum 1 was done, and so I loaded drum 2. Thanks to the recently improved reliability of my milling machine on several fronts, things went just as well the second time. In fact, with my realization that the Monster 3-flute was quite happy to rough in the absence of flood coolant, the chips were absolutely flying. And with just a little more action from the 6mm and chamfer tool, my second first operation was complete. Which means we can finally see the first feature of my efforts to break from tradition and bring some excitement to the world of indexing. I'd given the output side of each drum a few more teeth, so instead of 1 measly tick per rotation, we'd get 9, hopefully helping the whole thing at least appear random. And the fact that they're inside out allows for all of its bits to sit within a sleek cylinder, rather than having to hang out the back, like some kind of mechanical prolapse. If you like sleek cylinders, you should like the video, and if you subscribe, I'll know you want to see more. The final 2 drums were a similar story, with similar incremental improvements to the process. And before long, I had a stack of 4 very shiny and very half-complete parts. What I didn't have was an end mill small enough to reach into the root of the gear teeth I'd need to sculpt in Operation 2, so I shifted focus to the brass end of the build. At first, I really considered machining these carry gear mounting arms on my new 4th axis, which would have let me hit basically every feature in a single... What's that? Oh, this old thing? It's nothing really, just a little something I threw together after the controls upgrade. Okay, so it might be a servo-driven strain wave reducer rotary 4th axis with crossed roller bearings, closed loop encoder feedback and a brake. And despite all that talk of DFM earlier, I somehow ended up designing parts for this thing that kind of assumed the fourth axis would be finished with enough time to tackle this project. Which, in my defense, felt totally reasonable for the first 80% of the build. Thankfully, for the second 80%, I had the help of today's video sponsor, PCBWay. This is very exciting. And don't let the name fool you. Aside from being a leading manufacturer of custom printed circuit boards, PCBWay provides a comprehensive range of CNC machining services as well. All I had to do to get a quote was upload my CAD files and some technical drawings. And thanks to their lightning fast turnaround, I was finally able to properly send Pareto's principle packing with this parcel of panels. Oh yeah. And a faceplate, prettier than a peacock on a pirate ship. Now, this side project will eventually get its own video, but as we'll soon see, this video wouldn't have been possible without the continued support of PCBWay. So click the link below and find out what they can do for you. We'll get back to some 4-axis action a little later on, but I had a different plan for these particular parts. The recent sale of one of my kidneys facilitated the purchase of a couple more of these self-centering vices. They're intended for use on 5-axis machines, which is something I fully intended this one to be by now. But fortunately, they work just fine with 3 axes as well. And because I've got 3 of them, Op 1 on the 3 carry gear carry arms was as easy as running the same spotting, drilling, roughing, and finishing passes. At 3 work coordinate offsets. After dealing with the hail of chips produced by the drums, and the anxiety that came along with it, this free machining brass was a breath of fresh air. I'm pretty sure I could cut the stuff with a butter knife, and one day I might just try. This first operation was concluded by giving each arm its own unique keyway cutting experience to make sure they line up just right when the whole thing gets put together. As is tradition, the work holding for Op 2 was a little less straightforward. I'd been saving these removable soft jaws for a special occasion. So in the spirit of Christmas in July, in August, I decided to treat myself to the satisfaction of a delectably negative cavity to cradle and locate these very shiny almost parts for their final encounter with fate. Lovely. Things are going pretty well so far, don't you think? I mean, I sure did. I hadn't even broken a single end mill. No doubt most of the credit for that goes to the new spindle. But if a good tradesman never blames his tools, surely he gets to take credit for the wins, right? Too bad I'm not in the trades. So besides the sinus infection I'd managed to acquire from the aerosolized petri dish of water-soluble flood coolant, what the f***? My spirits were high, but while the rise to fortune is many steps, the descent was only one. Broken end mill, I mean. Well, that was never gonna work, obviously. All those oh-so-freely machining brass chips had clearly gone to my head, resulting in the foolhardy decision to remove the 6 carry gears from their stock with a simple full slotting ramped contour, saving me a boatload of setup time. Instead, I saved less than no time. God damn it. And this little guy paid the ultimate price. The next plan for the stock wasn't much brighter. Though on the bright side, I did manage to dull my biggest annular cutter and desecrate a parallel. Oh, no. As much as it pains me to say this, I was really starting to feel like an engineer. I mean, even if, by some miracle, I'd succeeded in producing 6 disc-like pieces of stock, actually holding them on the mill was always going to be an entirely additional set of headaches. I took a step back to blow off some steam, and realised that
Wait a minute.
the machine that's really good at cutting squares is probably quite well suited to holding them. Obvious in hindsight, but it still felt like a win. And with my head finally back in the game, I had some brand new ideas about how to attack this not quite so free machining alloy. Op 2 was to occur atop a trio of temporary fixtures. Just some small aluminium offcuts, faced, drilled and tapped. A pentad of pins got the stock close to alignment, so I could finish the backside and add a nice chamfer. Adding another couple of threaded holes allowed me to countersink the central bolt hole, and with that, I had 3 lovely looking pairs of carry gears. The end frames were next, and posed a unique yet familiar set of challenges. So to make sure I'd be able to hold and locate them for Op 2, I gave their stock a smattering of really quite nicely fitting holes, spaced to match the little fixture plate that could, an 8mm end mill with a modest 1/2 mil corner radius. Made short work of the top face, and with a better understanding of how this material liked to be tickled, I decided to have another crack at a full slotting contour. Stopping about a 1/2 millimeter from the whole way through. Using a fresh and uncoated cutter with a grind specifically designed for non-ferrous shenanigans made a world of difference, and with some small tweaks to my feeds and speeds, I actually managed to regain my will to live in its entirety. Once chamfered, I could flip it over and finish it off. With a key slot for the central shaft, some pinholes for the rear brace, and 3 tiny little 1.5mm slots that would locate the shell. A backside chamfer cleaned up the leftovers from our slotting, save for a few tabs, which were easily addressed with a quick hand job. It was the same story for the other end, minus the extra hole for our hand crank's gear train, and by that point, there was even more good news.
I love the postman.
Oh, and don't worry about these offcuts going to waste. They went straight back into the entirely useless for almost any purpose, but definitely perfect for something someday bucket. I finally had my hands on the tiny tooling I needed to start Operation 2, 45 internal gear teeth boogaloo.
We can finally cut our gear teeth.
This eeny-weeny uncoated 3-flute was about the smallest cutter I felt comfortable relying on for this crucial part of the project. But it should be perfect for reaching into the filleted root between the teeth, which is most of the reason they were an almost comedy-sized Module 3. I used shoulder bolts to hold the half-finished part to the fixture plate, but with their fit being a little loose and the concentricity and rotational alignment of these teeth to those ones being slightly essential, I made use of my probe to find zero, as well as measure the angle of the thoughtfully pre-machined edge, setting my work coordinate offset rotation to match, saving me a not insignificant amount of time with a dial indicator. When I was designing the drums, I chose a tooth count of 45 on the output side. Which, aside from being an odd number, means these parts will end up more than twice as toothy as our example. I mentioned that each time the carry gear is indexed, we get 2 teeths worth of rotation, meaning that any even number of teeth would only give us half that number of index locations. But an odd number of teeth means we'll eventually land on every tooth. giving our 3 display drums, each with 45 positions, a total number of possible combinations, just a hair over 90,000. Which should be enough to keep Alec going for at least a year or 2.
So, it's probably prudent to do a test fit of the arm and the gear to make sure that they run smoothly. Because if they don't, and I part this thing out, then I'm fucked.
A quick test fit with the brass counterparts confirmed I could continue up the creek without risking my paddle. So it was back to the big guy for an inverted boring operation. But while the addition of encoders to the mill meant circularity was at an all-time high, it was still an interpolation. And combined with the skeletal nature of these parts, I figured it'd make the most sense to save the last sliver of stock removal for the lathe.
This probably isn't the smartest idea I've ever had, but there's no real way of knowing until we try. What was I even worried about? That's gonna be a problem, that will more stick out. That's what I was afraid of. It's a lot better. God damn. Well, you won't even see that face, so it's fine.
With less than no time to stop and admire how well these parts had turned out, I stopped and admired how well these parts had turned out. And in such good time. I mean, in just over a week, I'd managed to complete like 80% of the project. And aside from the sheet metal shell, all I had left was some engraving and a handful of brass parts and steel shafts. This was going to be a walk in the park. Except it wasn't. Because while all these parts are close to, if not perfect copies of each other, everything else was one of a kind, requiring individually tailored stock preparation, programming, and setup, with a fair amount of manual intervention thrown in for good measure. I did manage to cook up one shortcut in the form of a gear cutting macro, which takes a handful of variables, tooth count, root depth, and the like, and automatically calculates the required absolute angle in order to avoid rounding error for each tooth. That being said, I spent a whole day getting it to work, and I still had to make a custom arbor for each of the 4 gears' unique method of attachment. And there was no macro to save me from the monotony in laying out the 45 video title elements and accompanying engraving toolpaths for the first, second, and third drum. You're not going to believe this. There's a bloody typo. Have a look at this. What the hell's a neat matter?
This is definitely the most work I've put into a punchline in my entire life.
But really, apart from some inadequate clamping forces and a highly regrettable G0Z0 command,
Oh, you're kidding me. Let's see what we can do here.
I was still making great time, ticking parts off the list, one by beautiful one. The central shaft, essential to the whole operation, with its integrated keys and keyway. And its like but not quite compatriots in charge of constraining each pair of carry gears, the input gear hub, with its effortlessly milled M16 thread. Then the skeletonized handle, and its low profile, yet highly personalized retainer. The beautifully blended rear brace. With its delicately engraved archaeological clues. And almost finally, the faceplate. dripping with engraved irony, its gaze eternal, and its wisdom highly questionable. My pile of parts was now just one step from pre-assembled, but the final component definitely deserves a pinch of preamble. I mean, the fact is, I already had everything I needed to assemble a mighty fine video title generator. But just like the element of surprise, at least part of the trick to a good joke is the element of surprise. And with this contraption well on its way to become the most protracted premise I'd ever assembled, I knew I had to do something to preserve the novelty of its 91,125 punchlines. And that something was a stainless steel shell. Now, I don't have a slip roll, but a night in the circular stuff corner of the workshop was just enough to bring the sheet around. Some printed rings and a form-fitting heatsink helped keep it that way, while I added some tender tack welds and did what little I could for the angle ground edges. Then, 6 holes drilled slightly out of position. What is it with me and holes in sheet metal? Led me to what I can only describe as the third most tragic moment of my professional career. Putting on a brave face, I got on with a little chain drilling and die grinding, until the handmade nature of these windows was hidden behind their faceplate.
Today is the 25th of July. I haven't even started writing the video, but this guy has this little scratch. And honestly, I can't stand that. So I'm gonna polish it.
So polish it, I did.
So I can't say for absolute certain, but after about an hour of polishing, I think it might actually be worse than when it started.
Having successfully rearranged my regret, I turned my attention to attaching the faceplate with a collection of improvised rivets, paving the way for the second and first most tragic moments of my professional career. The disappointment I felt was like that of a man having stepped from the shower, only just now realizing he needs to take a shit. But with no time for a do-over, I'd just have to brown bag these blemishes and move on to assembly. Firstly, the carry gear arms and the carry gears themselves have some magnets fitted, because unfortunately the half of its teeth trick doesn't work all that well to constrain the output when you've turned it and the input inside out. And I know there's problems with using magnets too, but for version 1, I'll just have to install the bearings and attach the carry gears with a countersunk brass machine screw and a dab of 243. The other two were the same deal, and then I could start stacking the frame. Just like the carry gears, gear 3 in the train is keyed to a shaft that passes through a pair of miniature bearings. But on the other side of the frame, gear 2 has a trick up its sleeve in the form of a sprag clutch. Press fit into a lobed bore. This needle roller assembly acts as a bearing in one direction and a brake in the other, making the handle a fantastic fidget spinner in the anti-clockwise direction. A short stud connects the central shaft to a standoff through the frame, so the input gear with its hub and bearings can be held in place. The flats make sure the handle stays in sync, and it's held in place with the mark of the man it was made for. 2 nubs using grubs as studs complete the human input side of the assembly, but the final drive gear takes us into the belly of the beast, being fitted to the hub of the first drum with some more magic glue. The whole drum slides wholly onto the central shaft, alongside some shims. Then I can carry on with the first of the carry gear arms and its key, kept in place with an itty-bitty M3 grub screw. Adding another shim means that the first, or last, depending on how you look at it, engraved drum can take its place. Then it just takes another arm, key, shim, drum, arm, key, shim, drum, and shim. to fully populate the length of the shaft. So I can turn my attention to the shell, which mercifully fits those little slots in the frame like a glove. Alignment is achieved with these reliefs in the faceplate, and once the second frame piece is pinned to the brace, and both are installed, the shell is clamped in position with its join neatly hidden. And just like that, the job was done.
Atravesando el silencio de la noche, otro otoño acababa de empezar, aunque estaba uno al lado del otro, estaban lejos y sin poder hablar. Sin embargo, no volvemos a callar.
Look what I got. What do you think it'll be? Any guesses?
I have no idea.
I hope it's that nice radius turning tool he's been making. It's not going to be that, but it'd be funny if it was.
Why am I like so nervous?
What the hell's this? We'll get the thumbnail shot. Oh my god! Just kidding. I can't actually see it yet. I'm one of those people who's really annoying about being careful when they unwrap things, you know, save the paper.
Oh, and you'd feel so disappointed if you ruined it when you...
Yeah, I don't want to scratch it. It's like one of those pass the parcels. My dearest Rowan, enclosed you will find a gift you will either love or loathe. A puzzle. Ah, sick. I'm gonna love it, obviously. Nothing is certain when you can't see the maze. A puzzle made specially for you. This is what I get for skipping open source. Punishment. And within that puzzle, a treat I am certain you will appreciate. Should you choose to attempt, no tools are permitted. Does a torch count as a tool? No excess force is required, and you must time yourself for my own personal satisfaction. I'm supposed to be editing the video. I would love to Brandon. With love, Brandon. I don't know if I'll be able to solve it right now. Depends how tricky he's made it. I am a clever cookie though, so.
And modest, too.
Yeah, exactly. If that's the thing, I'm gonna be sad with myself. Whoa. It gets heavy once you can see how big it is.
Is this the puzzle?
Is this the puzzle? It feels like it might be. Oh my god. Oh yeah. Okay, this is gonna be sick. A red herring.
He did a video recently where he made a puzzle.
He's done a couple.
Yeah.
Maybe we should watch those first. Incredible.
I think it's a twisty.
There's gonna be some really interesting trick. Which will be revealed. No tools are required, so I don't need... Do you just have really spindly fingers? You know what would be funny is if the video came out before I'd figured out how to solve it.
It's actually very possible.
It's only like a few days until that happens. That could be a red herring. He could be trying to trick it.
That's true.
Oh, look, you can see the brass inside. I mean, obviously pushing that is something. Why is it suddenly difficult? There's no extra pieces, are there? I'm amazed, because it looks like a pipe bomb. It got here so quickly. Also, that gets stuck when you, so obviously and that's tight. What if it was all a red herring? What if the letter was the red herring and you do need tools and excess force? A little bit of movement that way, but not that way, which is interesting. Oh, I'm a genius. Look at that. Look at that.
Does it spin off now?
No. Oh, wait.
It didn't do that before, did it?
You've unlocked something on the inside
Oh my
now.
god. Okay, so step one was to press this guy and push, and then we could turn this, which popped it back up. Okay, that's interesting. So, wait. So now that's locked. So that guy slides. I don't know if I'm meant to turn that. Can't go that way. Can't go that way. That's so clever, that tiny little bit of slop in the lid gave it away. It feels like a plunger. Wondering if there's any other ways to pull it. Oh, there was.
Huh.
It's a maze that you can't see. So remember, this timer is plus 8 minutes. I love mazes that I can't see. So yeah, that moves, follows these slots. Can I go down there? Not quite. So that can't push in anymore. That's a red herring. Seems to be a red herring.
That sounded like it did something.
Did it? Wait, that's a red herring. So basically there's all these paths. It's a maze.
Yeah.
And this pin is engaging, and I can see that there's a path to take down here, so I just need to backtrack to here.
Wow.
That's a bloody left-hand thread, isn't it? You cheeky bugger. Very
He's giving you a tool.
Oh yeah, there's a pin in there, do you see? So we need to go back down slightly. Now I could probably... No excess force. Yeah. Oh, and then...
Oh.
Interesting. I think I have to backtrack. We're at 20 minutes so far. Beautiful dovetails. Because I'm wondering if I go and then rotate that around.
Every good puzzle makes you backtrack at some point.
Well, this is a great gift. I tell you what.
Fun for the whole family.
Maybe I had it right before and it wasn't a red herring. And that lines up perfectly. The spring's a little bit in the way. Not sure if that's intentional. There's nothing to poke there. I can see a hole. Does a torch count as a tool? Couldn't help but notice you didn't chamfer these edges here, Brandon. Very, very disappointed. I want to know how it sucks back in like that. It's amazing.
Do you want this chair?
No, I'm good. I got my power stance.
Put your weight behind it.
What are you still doing here? Go and watch the playlist. It's really good.